Hi everyone. Today we are going to talk about uniform circular motion. Before proceeding for uniform circular motion, let's spend some time in understanding what exactly is a circle. So circle is a geometric structure which is defined mathematically by this form. Like if there is a circle, then the ratio of its perimeter to its diameter will be pi, that is 22 by 7. This is a very basic definition of a circle. This is how one can say if a geometry is a circle or not. Now, what we will consider is that in a circle with center here and of radius r, there is a particle at this point which is moving along this perimeter. At this point the velocity is v. After some time it reaches here and its velocity remains same, v, but its direction changes and it sweeps an angle theta here. So what we can say about the velocity and the perimeter and the radius is that velocity is basically distance divided by time. So the total distance or the total displacement here is 2 pi r, that is the perimeter of the circle, divided by time, which we can write that v by r is equals to 2 pi by t. There is another concept which is called radian. So if in a circle a particle goes from here to here and sweeps an angle theta and it covers a distance x here, this distance is x, then we can say that theta is x by r. This is how radians are defined. Now consider that the particle makes a complete circle. That is, if theta is equal to 360 degree, then this formula will be 2 pi r upon r, which will be 2 pi or 1 radian. So basically 2 pi is radian per cycle. That is, if a particle goes from here and complete one full cycle, then 2 pi is radian per cycle. Let's talk about the angular velocity, that is at what rate this theta is changing. What I mean to say, let us say angular velocity omega, this is angular velocity, is d phi by dt, the rate of change of angle, that is called angular velocity. This will be radian per unit time. So one complete radian is 2 pi by time. Radian per unit time, second. So from this equation and this equation, we can say omega is equals to v by r. So angular velocity omega is rate of change of angle, and for one complete cycle, that is for 1 radian, the time taken is t, then the angular velocity will be 2 pi by t in radian per second. And since omega is 2 pi by t and velocity is also v by r is also 2 pi by t, that means omega is equal to v by r, or that is how velocity and particle velocity and angular velocity are related. V is equals to omega r. This is a very important term in understanding uniform circular motion, the relation between angular velocity and linear particle velocity or momentary particle velocity v. Another concept is called frequency, which is how many cycles per second it travels. So we know that omega is radian per unit time, and 2 pi is radian per cycle. So from here we can simply write frequency will be omega upon 2 pi. So frequency will be 2 pi by t, that is omega, from here, multiplied by 1 upon 2 pi, which will come 1 upon t. So frequency is 1 upon the time of oscillation, or time of one circle. Now let's talk about the acceleration. Since the particle is moving from this point to this point to this point with the same velocity, with a uniform velocity, that's why this study is called uniform circular motion, but its direction is changing, means there is a certain kind of acceleration which is happening. So what is that acceleration? Now if this is a circle, sorry for that, and at this point this is the center, when the particle was here, its velocity was v. Then when the particle moves here, its velocity is in this direction of the same magnitude v. Then it moves here, then its velocity is v. Then it moves here, velocity is again v in the same direction. So it keeps on changing this, changing its the direction of the velocity. Let's consider a point P here, or for that instant x here, with a radius vector r. What will be the coordinate of this x if this angle is theta? We can say that this length is r cos theta and this length is r sin theta. That means x is having a coordinate of r cos theta comma r sin theta. So we know this x position vector is having a coordinate of r cos theta comma r sin theta. Now in order to get the velocity, we can write dx by dt. If the rate of change of position is velocity, that will give us, now I have to differentiate this equation with respect to t, but there is no t here, so I need to consider theta. I need to differentiate it with theta and then have to write like r minus r sin theta d theta by dt comma r cos theta d theta by dt. From here we know that d theta by dt is omega, so we can write this as velocity is minus r omega sin theta comma r omega cos theta. Now if we look into the rate of change of velocity dv by dt, we will get acceleration, which will give us minus r omega cos theta. The sin theta will become cos theta comma d theta by dt comma r omega sin theta. This will be a minus d theta by dt. Again we know that d theta by dt is omega, so we can write acceleration as minus r omega square cos theta comma minus r omega square sin theta, because d theta by dt is omega and omega multiplied by omega is omega square. So if we take minus omega square here, what we'll left with r cos theta comma r sin theta. If we look into this equation closely, this r cos theta sin theta is nothing but our position vector x, or so we can write acceleration is equals to minus omega square x. So what is the magnitude of this x? What is the length of this position vector here from here to here? That is the diameter of that is the radius of this circle. So we can write as a is equals to minus omega square r. And from here it is very clear that a is in this minus side indicate a is in opposite direction to r. So it is towards the center of this circle, and this acceleration is called centripetal acceleration. Centripetal acceleration is towards the center of the circle. Means if the particle is here and if it moves here, then here and here, so all the time the acceleration was happening towards the center of the circle. Only then the particle was having a constant velocity yet changing its direction. Also, so this is important derivation here. Also we know that omega is from here, omega is v by r, so we can also write it as acceleration. The magnitude of acceleration is v square r square multiplied by r, or acceleration is v square by r. This is how centripetal acceleration is related to the particle velocity and related to, and here it is shown how it is related to the angular velocity. Now we've used differential calculus to find out the acceleration. There is one other easy method as well to prove the same. If we look into this circle here, we have seen that when the particle was here, its velocity is in this direction, then it goes, the velocity is in this direction, same magnitude, and again here and here. So this is how the circular motion was getting completed. This distance was r. So what is the time for this particle at this point to move the whole circle? Time is basically distance divided by speed. So your distance is distance divided by speed. 2 pi r is your distance and your speed is v. Also, if we make a new circle with only the velocity vectors there, so at this point the velocity vector is in this direction, after some time the velocity vector is in this direction, then the velocity vector is in downward direction, then in this direction. Basically you will end up having something like this. All of these are v, the velocity into different direction. So this will also constitute of a circle where the velocity change from this point to this point to this point is acted upon by acceleration here. Acceleration is acting here, perpendicular. So what is the time taken by this particle to move from here to here? That will be distance, that is 2 pi, here there is no r, there is v in this vector circle, by a. So since the time taken for the particle to move from this point to this point is same, and for changing the velocity from this point again to coming back to this point is same, then we can equate these two, this equation and this equation. These two equations we equate, so it will become 2 pi r v is equals to 2 pi v by a. So from here 2 pi will get cancelled, and you will get acceleration is equals to v square by r. So this is how geometrically you can also prove how the acceleration is related to the particle velocity. I hope this video helps you in clearing some of the concepts of your uniform circular motion. We'll see you in next video with some more examples on uniform circular motion and how to use these equations in uniform in solving the problem of uniform circular motion. Thanks. Don't forget to like, subscribe and share the video. Please leave your feedback and questions in the comment section below. Press the bell icon to get instant update from the channel Hands on Physics.